In this video, we are continuing the CET and JEE questions on current electricity chapter. Next question. If R1 and R2 are respectively the filament resistances of 200 watt bulb and 100 watt bulb designed to operate at the same voltage, then option A, R1 is 2 times R2. Option B, R2 is 2 times R1. Option C, R2 is 4 times R1. Option D, R1 is 4 times that of R2. Now, solution will be solved like this. Given that R1 and R2 are respectively the filament resistances, we have to find out R1 and R2 first. And R1 first bulb resistance, first bulb power of first bulb will be 200 watt and power of second bulb will be 100 watt, designed to operate at same voltage. Voltage V1 will be equal to V2 will be equal to V. Now, we know that what we know means power will be equal to V square divided by R. We know that P equals V into I. I will be equal to V by R. Then that will be equal to V square divided by R. Now, I want resistances. R equals V square divided by P. Now, I need resistance of first bulb R1 should be equal to V square divided by P1. Now, V will be same. V square divided by P1 should be 200. Next, R2 we have to find out R2 by same formula, V square divided by P2. V square will be same. P2 will be 100 watt. Now, I need the ratios R2 divided by R1, that will be equal to V square divided by 100 whole divided by V square divided by 200. V square get cancels. 200 divided by 100, 00 get cancels. R2 divided by R1. R2 divided by R1 should be equal to 2 divided by 1. This implies we have to cross multiply. R2 equals 2 times R1. Hence, R is 2 times that of R1. Option will be R2 is 2 times R1. This will be the answer, option B. We have to solve like this. Now, next question is 2 electric bulbs 40 watt, 200 volt and 100 watt 200 volt are connected in series. Then the maximum voltage that can be applied across the combination without fusing either bulb is option A 200, option B 300, option C 400, option D is 280. Now we have to solve like this. Solution: 2 electric bulbs 40 watt, power of first bulb will be 40 watt and voltage of first bulb will be 200 volt. Power of second bulb will be 100 watt and voltage of second bulb will be 200 volt. Those are connected in series. Then the maximum voltage applied means first we have to find out current flowing through first bulb and current flowing through second bulb. Now, next we have to solve for resistance of first bulb and resistance of second bulb. Those two are connected in series means R1 plus R2, series combination of resistances we have to find out on the bulb. Then we have to find out total potential across the bulbs in series combination. Now, I will find out. We know that P equals V into I. I need value of I. I equals P by V. For current flowing through first bulb will be I equals P1 divided by V1. P1 is 40 watt divided by 200. 0 cancels. 2 2s are 2 10s are 2 by 10 means 1 by 5. 1 by 5 is equal to 0.2 ampere. Similarly, we have to find out I2, P2 divided by V2. P2 will be 100 watt divided by V2 will be 200. 1 by 2 will be 0.5 ampere. Now, in series combination, current flowing through the bulbs will be same. But here I have to find out current through first bulb and current through second bulb. In series combination, the minimum value of current is supplying across those bulbs. Hence, current flowing will be 0.2 ampere. Next, I have to find out R1. We know that P equals V square divided by R. From this, R equals V square divided by P. Now, R1 equals V1 square divided by P1. V1 will be 200 volt. 200 with square means 200 into 200 divided by 40. 0 0 cancels. 4 5s are 20. 5 2s are 10. Here 2 zeros. 1000 ohm. R2 equals V2 square divided by P2. V2 will be 200 volt. 200 into 200 divided by P2 is 100. 100 2s are 200. 2 2s are 4. 400 ohm. Resistance of both we can add for series combination of resistors. RS will be equal to R1 plus R2. That will be equal to 1000 plus 400 is 1400 ohm. Now, we know that by Ohm's law V equals I into R. R means in series combination of resistance I into RS. I will be 0.2 ampere into 1400. 0.2 will be written as 1 by 5 into 1400. That will be 5 2s are 10. Remaining will be 4. 40. 5 8s are 40. Here 1 0. 280. V equals 280 volt. Answer will be 280. Option will be option D. We have to solve the problem like this. Next question. The resistance of a metallic conductor increases with the temperature because option A, free electron density increases. Option B, conductor expands. Option C, number of collisions between electrons increases. Option D, number of collisions between electrons and vibrating ion cores of the conductor increases. We know that for solution, resistance of a metallic conductor increases with its temperature. If temperature increases, in metals, resistance also increases. And here option D is answer. Option C and option D are similar because number of collisions between electrons increases. Here also number of collisions between electrons and vibrating ion cores of the conductor increases. Here resistance in a metallic conductor, if temperature increases, number of collisions also increases with electrons and ion cores of the conductor, because in metals, if temperature increases, atom will be split up into free electrons and positively charged ions. Hence, vibrating ion cores also present in the conductor. Hence, those if temperature increases, resistance of metallic conductor also increases with number of collisions and vibrating of ion cores. Option D is answer. Next question. A metal wire is subjected to a constant potential difference. When the temperature of the metal wire increases, the drift velocity of the electron in it, option A, decreases, thermal velocity of the electron increases. Option B, increases, thermal velocity of the electron increases. Option C, decreases, thermal velocity of the electron decreases. Option D, decreases, thermal velocity of the electron decreases. Here we know the difference between drift velocity and thermal velocity. Drift velocity means the average velocity with which the free electrons get drifted in the direction opposite to the direction of electric field. Thermal velocity means the velocity due to the excitation of electrons by heat energy. Here we know that if temperature increases, resistance also increases. If temperature increases, number of free electrons also increases in a conductor, but drift velocity of the electron also increases due to increase in resistance. If resistance increases, drift velocity also increases. Means resistivity and resistance are directly proportional. If temperature increases, resistance and resistivity also increases, then drift velocity also increases due to its relaxation time. And also, we know that by Ohm's law, V equals I into R. If R equals V by I, if current decreases, resistance also decreases. Current and drift velocity are directly proportional to each other. I equals NEAVD. We know the relation. Here, if current decreases, resistance increases. If decrease in current will decrease in drift velocity, hence drift velocity decreases in this case. Thermal velocity due to heat energy, the excited electrons velocity due to heat energy will increase. Hence, the drift velocity of electron in it decreases, thermal velocity increases. Option will be option A answer. Answer will be option A. Fifth question. Vd is the drift velocity when a current flows through a wire. If radius of the wire is doubled for a same current, the drift velocity of an electron is. Here we know that for solution I equals NEAVD. Now drift velocity of when a current flows through a wire, Vd should be equal to I divided by NEA. For wire, area of the wire should be pi r square. If the radius of the wire is doubled for the same current will be same but radius will be doubled, then the drift velocity is given by Vd dash equals I divided by NE pi r by 2, radius of wire is doubled, 2r whole square. Vd dash equals I divided by NE pi, 2 2s are 4, r into r square. Now we know that Vd dash will be equal to I divided by NE pi r square will be written as Vd. Remaining will be 4 in the denominator. Therefore, Vd dash equals Vd divided by 4. Option will be option C. Option C. Next question. A wire of resistance 9 ohm is uniformly structured such that its radius becomes 1 by 3 of original radius. Ratio of the new to old resistance is option A 3, option B 9, option C 27, option D 81. Now we have to solve like this. Resistance will be 9 ohm, uniformly structured such that radius becomes 1 by 3. Old radius will be R only. R dash will be equal to new radius, R dash will be equal to R by 3. Ratio of new to old resistance, R dash divided by R we have to find out. Now, if radius will be given, wire is having area of cross section pi r square. For new radius or new wire, a dash I will taken as its area will be a dash, pi r dash square, r dash will be r by 3, pi will be written as like that only as it is, r dash will be r by 3 whole square. Then a dash should be pi r square, 3 3s are 9. Pi r square will be written as a, or replace pi r square as a divided by 9. A dash should be a by 9. Also, volume of first wire should be, volume will be equal to area into its length. Volume, new volume should be V dash, or V, volume of the wire will be same. For new volume, V equals A dash L dash. V should be equal to A into L. A dash should be A by 9 into L dash. A and A, LHS A and RHS A will be get cancels. Therefore, L dash should be equal to 9L. A dash is A by 9. L dash should be 9L. R dash should be R by 3. Now, we know that R equals rho L divided by A. This is old resistance. New resistance will be written as R dash equals, resistivity will be same because it is made up of same material. L will be L dash divided by A dash. Rho will be same. L dash should be 9 into L. A dash should be A divided by 9. Now, R dash should be written as 9. Denominator of denominator 9 should be goes to numerator, 9 into 9 into rho L divided by A. Rho L divided by A should be replaced as R, that is old resistance, 9 9s are 81 R. I need the ratio R dash divided by R, that will be equal to 81. Answer should be option D. We have to solve like this. Next question. A conductor wire having 10 power 29 free electrons per meter cube carries a current of 20 ampere. If the cross section of the wire is 1 millimeter square, then the drift velocity of electrons will be given that E equals 1.6 into 10 power minus 19 coulomb. Option A, 6.25 into 10 power minus 3 meter per second. Option B, 1.25 into 10 power minus 5 meter per second. Option C, 1.25 into 10 power minus 3 meter per second. Option D, 1.25 into 10 power minus 4 meter per second. Now, we have to write given. First of all, number of free electrons should be 10 power 29 free electrons per meter cube. Current will be 20 ampere. Area of cross sectional area should be given as 1 millimeter square. 1 millimeter should be 1 into 10 power minus 3 whole square, means 10 power minus 6 meter square. We have to find out drift velocity given that E equals 1.6 into 10 power minus 19 coulomb. We know that I equals NEAVD. We know the relation between drift velocity and current. I equals NEAVD. We have to find out VD, the drift velocity, I divided by NE into A. I should be 20 ampere divided by N will be 10 power 29. E should be 1.6 into 10 power minus 19. Area of cross section should be 1 into 10 power minus 6. VD equals 20 divided by, if bases are same, I will add powers. 10 power 29 minus 19 should be 10. 10 minus 6 should be 4. 10 power 4. This 10 power 4 will transfer to the numerator. Vd equals 20 into 10 power minus 4 divided by 1.6. This 1.6 should be shifted. Its point should be shift. 20 divided by 16. In numerator 10 power minus 4. In denominator, if we shift the point towards the right, 10 power minus 1 will be its power. 4 4s are 16, 4 5s are 20, 4 1s are 4, 1 remaining, 4 2s are 8, 2 remaining, 4 5s are 20. Vd should be equal to 1.25 into 10 power minus 4. In denominator 10 power minus 1 will be there. It can be transferred to numerator 10 power plus 1. Vd equals 1.25 into 10 power minus 3. Unit will be meter per second. Answer will be option C. Answer is option C. We have to solve like this. Next question. A resistor has a color code of green, blue, brown and silver. What is its resistance? Now, in tabular column of color coding of a resistor, we have to remember a sentence that B.B. Roy of Great Britain had very good wife wearing gold, silver necklace. Here, first B is black, whose code will be 0. Next B will be brown, whose code will be 1. R is red, whose number will be 2. O is orange, number will be 3. Y is yellow, number will be 4. This G will be green, number will be 5. This B is blue, number will be 6. V is violet, number will be 7. This G will be grey, number will be 8. This W will be white, number will be 9. We have to go from dark color towards light color, and gold will be, this band will be along fourth color or fourth band. Gold will be having 5% tolerance, silver will be 10% of tolerance, N means none, no color, which will be 20% of tolerance. Now, we have to find out the value of resistance. R will be equal to, first will be green, green having number 5. Next one, blue, blue having color number code 6. It can be multiplied by third band will be multiplier 10 power. Brown should be having 1, 10 power 1 ohm. We have to write the resistance value. Tolerance will be either plus or minus. Plus or minus, given will be silver. Silver will be having 10%. 10%. We have to simplify. R equals 10 power 1 will be 10. 10 into 56 will be 560 ohm, plus or minus 10%. Option will be option C. 560 ohm plus or minus 10%. Next question. Wires made up of iron and silicon is cooled from 50 to 30 degrees Celsius. Option A, resistance in both the wires decreases. Option B, resistance in both the wires increases. Option C, resistance of iron increases and that of silicon decreases. Option D is resistance of iron decreases and that of silicon increases. We know that for solution, we know that in metals, if temperature increases, resistance also increases. In non-metals or in semiconductors, if temperature increases, resistance decreases. Since Resistivity and resistance are directly proportional. If temperature increases, resistance increases in metals. In semiconductors, temperature increases, resistance decreases. Here, in the given question, first temperature should be 50 degree, second temperature will be 30 degree. Hence, temperature goes on decreasing. Here, iron is a metal. If temperature decreases, resistance also decreases in metals. In semiconductors, if temperature decreases, resistance increases because silicon is a semiconductor. Hence, resistance of iron decreases and that of silicon increases. Option D is right answer. Next question. Three resistance of values 2 ohm, 3 ohm and 6 ohm are to be connected to produce an effective resistance of 4 ohm. This can be done by connecting option A, 6 ohm resistance in series with a parallel combination of 2 ohm and 3 ohm. Option B, 3 ohm resistance in series with parallel combination of 2 ohm and 6 ohm. Option C, 2 ohm resistance in series with parallel combination of 3 ohm and 6 ohm. Option D, 2 ohm resistance in parallel with the parallel combination of 3 ohm and 6 ohm. Now, in the above question, 3 resistance 2, 3 and 6 ohm are connected to produce effective resistance. Last final value will be 4 ohm. How we can connect? 4 options will be there. We have to solve all the 4 options in which effective resistance will be 4 ohm, which is the final answer or which is the solution for that question. Solution in option A, 6 ohm resistance is in series with parallel combination of 2 ohm and 3 ohm. This will be 6 ohm, 2 ohm, 3 ohm. Next, in sub-question B, 3 ohm resistance in series with parallel combination of 2 ohm and 6 ohm resistance. 2 ohm, 6 ohm, this will be 3 ohm. In option C, 2 ohm resistance in series with the parallel combination of 3 ohm and 6 ohm. 3 ohm, 6 ohm, this will be 2 ohm. In option D, 2 ohm resistance in parallel with parallel combination of 3 ohm and 6 ohm. This is 2 ohm. This will be in parallel combination with 3 ohm and 6 ohm. 2 ohm, 3 ohm and 6 ohm. We have to solve all these. In first option, 6 ohm. 6 plus in parallel combination 2 3s are 2 into 3 divided by 2 plus 3. This will be 6 plus 4, 2 3s are 6, 6 divided by 3 plus 2, 5. 5 1s are 5 point, 5 2s are 6 plus 1.2 will be 7.2, which is not equal to 4. Second option, 3 ohm, 3 plus 6 2s are 12 divided by 6 plus 2, 8. 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6. If we are cross multiplying or take LCM, 2 divided by 3 2s are 6 plus 3, 9 by 2. 4 point, 2 4s are 8, point 4.5 ಬರ್ತಾ ಇದೆ. Next, in sub question C, in option C, 2 ohm plus 6 3s are 18, 18 divided by 6 plus 3, 9. 9 2s are 18, 2 plus 2, 4. This will be right answer because equivalent resistance value will be 4. 4 will be equal to 4. We have to solve like option 4. Here 2 ohm. These two combinations will be 6 and 3. 6 3s are 18 divided by 9. That will be 2. 2 ohm is in parallel with 2 ohm again. 2 into 2. 2 2s are 4 divided by 2 plus 2 4. 4 divided by 4 will be 1 ohm. Option will be option C. 2 ohm resistance is in series with parallel combination of 3 ohm and 6 ohm.